Hello everybody, this is Professor Ross here to talk about fraction multiplication. So, as we've seen before with other computational things, there's a lot of value when we teach fraction multiplication to allow students to invent strategies before you come to the traditional algorithm for multiplying fractions. And that can be especially important with fraction multiplication because the traditional algorithm is fairly easy to do. You just multiply numerator times numerator and denominator times denominator. But understanding why that works is a little more complicated. So letting students explore problems and figure them out for themselves can be a real valuable thing. It's always good to work to make connections between the meaning of fractions and operations. So you want students to be thinking about what multiplication means and also what the fractions and the numerators and denominators mean. You want to use a variety of models, but we'll find that focusing on the rectangular area model can be especially helpful with some of the most challenging types of problems in fraction multiplication. And we want to provide problems for students along a trajectory. So we want to start with the easiest type of problems and move towards the most difficult type. And I've got 4 steps here that these problems tend to follow. And let's start by talking about the first type, fractions of whole numbers with no splitting of wholes. Let's begin by thinking what it means to multiply and what fractions mean for a scenario like 2/3 times 6. Multiplying still has the same meaning as always. We want to make equal groups. So, and we could think about this 2 ways with multiplication. For this problem here, 2/3 times 6, we could think about that as 6 groups of 2/3 or as 2/3 of a group of 6. And depending on the context, one of those will probably make more sense. For example, if we look at this problem here, there are 6 cookies left. If you eat 2/3 of them, how many do you eat? Now we're not really talking about 6 groups of 2/3 each. We're more talking about 2/3 of a group of 6. So let's say we've got our 6 cookies here, and we want to eat 2/3 of them. How can we figure that out? Well, in order to know what that means, I have to understand what 2/3 means. 2, the numerator, tells me how many I have of 3, the denominator. My whole group has been cut into 3 equal parts. So if I look at my group of 6 cookies here, I want to cut it into 3 equal parts. And then I want 2 of those. So here's 1 of those thirds. And here's a second of those thirds. Looks like we have eaten 4 cookies. That's the easiest kind of fraction problem. We didn't need to do any kind of splitting our wholes into fractional parts or anything like that. We just need to decide how many fit into one of our denominator pieces here, thirds, and then figure out how many of those we have. More challenging is if we do fractions of whole numbers where we do have to split the wholes. Excuse me, I had the word no in there, but I mean splitting wholes, like 2/3 of 5. Let's go ahead and clean up our picture here and talk about a question like this. There are 5 cookies left, so I'm going to go ahead and just X this one out. It's not around. There are 5 cookies left. If you eat 2/3 of them, how many do you eat? Now, if I'm looking at 5 cookies and I want to find a group of 2/3 of them, if I'm really going to split this into thirds, that's going to be a much more challenging task than when I had 6 cookies. 6 cookies, it was easy because I didn't have to split up wholes at all. But if I'm going to split 5 into thirds, I've got to think about how I can split these wholes up. You can see how this is more challenging of a task than if we did not have to split the wholes. How can we do this one? There are a couple ways to think about it, but one way to do it would be to take each of the cookies and split them into thirds. And then we could realize that, okay, if I take a third from each cookie, that I would have a third of all of my cookies. So that would mean 1, 2, 3, 4, 5. I'll go ahead and mark those here. Would be 1/3. And then let's go ahead and mark these here as my second third with a little X here. 1, 2, 3, 4, 5. And so I have eaten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds of a cookie. And that leaves me with 5 thirds left. So that would be one way we could think about that problem. More challenging than when we didn't have to split the whole. We're going to see that the next two follow a similar path in that in one of them we don't have to split up the pieces we have. That's called unit parts without subdivisions, and that's less challenging than subdividing the unit parts. So we're going to switch our context a little bit here. Let's look at number 3. There is 6/7 of a pan of brownies left. If you eat 2/3 of what is left, how much of a pan of brownies do you eat? You can see that overall it's more challenging because now both of our numbers are fractions. And so as we think about multiplication, I'm not thinking about 2/3 of a group of 6. I got to think of 2/3 of a group of 6/7. Say I've got my pan of brownies over here, and I've got it split into sevenths, and we only have 6/7 left. So this guy here is not around anymore. And let's say we're going to eat 2/3 of what is left. Well, if I'm looking at this here, I've got 6 pieces here. 1, 2, 3, 4, 5, 6. And so what's 1/3 of those 6? Well, it's going to be 2 of them, right? Because if I put 2 of these pieces together, I'll have 3 groups there. So 1/3 of 6/7 is going to be like this, and 2/3 is going to be like this. And so I would eat this, and this, this, and this, and that would be 4 of my 7ths of the pan of brownies. So just like we saw when we had 6 cookies, we could pair them up to have thirds. When we've got 6/7, we can pair up those 6 pieces into 2 each, and that'll tell us we'll be able to make thirds from that. We eat 2 of those thirds. That's 4 pieces. Each piece is a 7th, so I've eaten 4/7 of the pan of brownies. Now, how does that compare to a problem where we must subdivide the unit parts like number 4 here, which we will see is more challenging? So let's take a look at number 4. There is 5/7 of a pan of brownies left. If you eat 2/3 of what is left, how much of a pan of brownies did you eat? Okay, so let's X out these couple here. These are gone. We've got 5/7 left. And now I need to take my 5/7 and find 2/3 of that. Just like when I only had 5 cookies, it's a lot harder to think about how I might take these 5 pieces and split them into thirds. Here's where the rectangular area model really comes in helpful, because if you're originally split, for example, here we're split horizontally, then we can split vertically to get the thirds that we need, like this and like this. Kind of like I took these cookies and split them into thirds. I've now taken the 7ths and I've split them into thirds. And I eat 2/3, so here's 1/3, and here's 2/3 of what was left. How much of a whole pan of brownies did I eat? Well, out of this whole pan, I've eaten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these things. What are these things? Well, if I've got a pan that's split 1, 2, 3, 4, 5, 6, 7 that way, and 1, 2, 3 this way, that means there's 21 of them all together. And so I've eaten 10 of those 21sts. Definitely more challenging. That's the most challenging kind of fraction multiplication problem. You want to build to that through the trajectory. And ultimately, once students understand and make sense of this, doing the traditional algorithm like 2/3 times 5/7, where 3 times 7 gives us 21, that now has meaning because I had 7ths one way and thirds the other way. And so if I multiply 3 by 7, I get 21 pieces altogether. Same thing with 2 times 5 gives me 10. I had 5 rows across and I wanted 2 rows vertically. 2 times 5 gives me 10, and this traditional algorithm now has more meaning. Good luck with teaching students to multiply fractions.